and welcome back. Today we're going to be covering lesson 89 and continuing our discussion of quadratic functions by learning to identify characteristics of quadratic functions. So again, recall, I'm going to sound like a broken record here, but recall the standard form of the quadratic function. And we already learned how to identify one characteristic of quadratic functions, and that is by looking at this first coefficient on the x squared term, we can determine if the graph opens up or if it opens down. So if it's a smile or if it is a frown. So we already know that, so we're already ahead of the game. We know that from our previous lesson. Now, when we're looking at a parabola shape, so again, it's sort of this expanding U shape, the turning point of a parabola, so if it opens up, the turning point is down here. It's where it starts from, it changes from going down to turning to go up. And if the parabola opens down, that turning point is up here. This is called the vertex. So there's some terminology that you need to know and remember. So the vertex, as I said, is, we can think of it as the turning point for the parabola. So if we're in a race car that's coming around a track, this is where we're going to turn and change direction as we're coming around this curve in the parabola. So that's the vertex. And if the vertex is the turning point of a parabola that opens up, this is the minimum value, isn't it? That's pretty easy to see because this is the lowest point of the parabola. So it's the smallest it's ever going to be, the smallest value that graph is ever going to be. And if that vertex is the turning point of a parabola that opens down, that's actually going to be the maximum, right? It's the highest number that graph is ever going to be. So the vertex can be either the maximum or the minimum, depending on whether the the parabola is opening up or down. And the good thing about this particular characteristic of the vertex is that it's really easy to just see visually. Is it at the bottom? Well, it's the minimum. The minimum's the bottom. Is it at the top? Well, it's the maximum. The maximum's the top. So that's not too hard to wrap our minds around. One of the things to remember with really any graph, but especially these more complex graphs, is which values in which part of the graph is the domain and which part is the range. So remember that when we're graphing anything, we have x and we have y, and remember that y is the same thing as f of x. So let's imagine that we have a parabola that opens upwards. And here's the vertex. Well, of course, the vertex is going to correspond to an x value, and it's also going to correspond to a y or f of x value. So sometimes we use the term the value of the function. And that is referring to the y value right here. So although the x value is important because we need both x and y to identify any point on the graph, when we're talking about the value of the function, we're talking about that y value because y is the same thing as the function notation. We can switch back and forth, remember, depending on what we're doing. So a lot of students get confused about what are you talking about? Is it x? Is it y? What is that? So I want to make it clear from the beginning that the value of the function is the y value. So when we talk about the minimum value, in this case, we're talking about what is that y value. And if we had a parabola that opens downwards, maybe it's looks like this. There we go. That would be the maximum value, and we're talking again about that y or the f of x value. So we'll just make that clear from the beginning so that when I use that terminology, you'll know exactly what I'm talking about. So the vertex has an x and y coordinate, and the minimum or maximum value is the y value of that coordinate point. Now, the other characteristic that we are really interested in for parabolas are where does it intersect the x-axis. Now, this is maybe a little bit different than what we're used to with lines. When we're graphing a line, we oftentimes think about where does it intersect the y-axis. But with the quadratic function right now, we're interested in where does it cross the x-axis. So I'm actually going to sketch out a parabola for us to look at. Get my x-axis there. So we'll put a few tick marks here, 1, 2, and 3, 1, 2, and 3. And so let's imagine that we're given this graph and we are also given the function. So the graph goes like this. Whoops. Let's see if I can make that a little bit smoother. There we go. And we're told that this function is f of x is equal to x squared minus x minus 2. And we want to know, where does this cross the x-axis? In other words, where is the x-intercept? Because it's crossing and intercepting means the same thing. So where is it crossing the x-axis? So remember, we have x and then we have y, or f of x here for our vertical and our horizontal axes. And here we see these 2 points. And sometimes, as you know from looking at a graph, it can be sometimes a little bit tricky to tell exactly where it's crossing the graph. It looks like this graph, where it's crossing the axis. So it looks like this graph is crossing the axis here at 2, 0, and it also looks like it's crossing the graph at -1, 0. But as you know, we can't always rely on just our eyeballs. So we need to test these 2 points. So we need to test or check those 2 points. So if we check -1, 0, let's plug that into the equation that we're given. So I'm going to actually erase our standard form here because we don't really need that right now. So if we have f of -1, and we want to know, so we're putting in -1, and it should give us back 0. So the f of x value that we should get should be 0. That's what we are checking from our point. So plug that in for f of x, and plug -1 in for x. So we have -1 squared minus -1 minus 2. And that's equal to +1 plus 1 minus 2, and 1 plus 1 is 2, minus 2 is 0. So, yes, that works. This is an actual point that's on the graph, and it does cross the x-axis there. So that is one of the points where it crosses the x-axis. So we'll go ahead and write that down as a definite yes. And now let's also test 2, 0. So again, we put in 0 is our y value, and for our x value, it's 2. So we should have 2 squared minus 2 minus 2. And that is equal to 4 minus 2 minus 2, and that is equal to 0 as well. So both of these points, my eyes did not deceive me. They are indeed where they cross the x-axis. So let's notice something here about these points. We'll erase some of this so we just have less going on the whiteboard. Notice something here. The y value is 0 for both of them. And that makes sense because when we are at the x-axis here, Of course y is equal to 0. Y is equal to 0 on the whole x-axis because we're down here and it's not plus or minus anything. It's just equal to 0. So when we talk about the x-intercepts of a quadratic function, we are talking about where does y, which is also f of x, remember, where does that equal 0? And in fact, we can sometimes call the x-intercepts zeros because of this fact, because it's the zeros of the function. It's where does that function equal 0, or where does it cross the x-axis. So one of the things that we have to remember that can sometimes be frustrating with these characteristics of quadratic function is that we oftentimes have 2 or more ways to say the same thing. And mathematicians do this a lot, right? And part of it is just because over time some people say one thing and some people say the different thing. And in the English language, words, we have equivalent words that are synonyms that mean pretty much the same thing. And so it's important to keep these things straight in your head and what words are equivalent. So this is one of those things that is equivalent. We use 2 different words for the same thing. So x-intercepts and zeros are the same thing. So don't get confused thinking that they're 2 separate things. No, they're not. They're the same, and it's simply where the function crosses the x-axis, which means the function is equal to 0 there because y is equal to 0. Just like we said that vertex was also could be called a turning point, or could be the minimum or the maximum, depending on the function. We have multiple ways to say the same thing. So it's an unfortunate consequence of the history of mathematics that we find ourselves in, and so, but we don't want to learn just one thing and then be confused when we see something else. So we do need to, as good math students, learn all the terminology. But I'll try to make it clear when these terms are equivalent. So sometimes we might look at a graph, as we did before, and test and see if we can find the zeros. Sometimes there are 2 zeros, like the graph that we just looked at, where the parabola went like this. And there were 2 places where it intercepted the x-axis. So that would be 2 zeros. Sometimes we might have a parabola that basically it's sitting on the x-axis. So it could be opening up or down, but it's just sitting there. And in that case, you only have 1 0. So if you're looking at a graph and you're testing a point, you only have to test 1 point. That's very, very handy. So you could test that 1 point, and if it works, then you know that that's a 0. You could also have a situation where we don't have any real zeros. You might have a parabola that kind of looks like it's floating up in space. That can happen too. In that case, there are no zeros. 0 zeros. So we might have 3 different situations with parabolas where we have 2 zeros, 2 x-intercepts, we have 1 0 or 1 x-intercept, or we have no zeros at all, and it's just floating there. So if you're given a graph and you're looking for the points to test, these are the situations that you might encounter. Let's think about one more characteristic of parabolas before we wrap up this lesson. And that characteristic is what we call the axis of symmetry. So I'm going to try to draw a really nice parabola there. That's pretty good. Pat myself on the back for that one. But all parabolas are symmetrical. We can draw a line through the middle of a parabola, and the 2 sides are the same. They're mirror images of each other. And this line that we can draw is called the axis of symmetry. And this is one that really doesn't have more than one name, just has one name. It's the axis of symmetry. And it passes through the vertex of the parabola. And again, the parabola is a mirror image. And so if that parabola has two zeros, the axis of symmetry is in between the two zeros. It is an equal distance from one to the other. So the axis of symmetry is really easy to see because you can just draw a line down the middle of that parabola. And most often we express the axis of symmetry using an equation of that vertical line. So it's always going to be a vertical line. And so it'll be x is equal to whatever the number is, whatever the x-intercept is where that crosses, which is going to correspond to the x value of the vertex. And that is it for this lesson, and I'll see you next time.